Welcome to this lesson. In this lesson, we're going to do acceleration. Now, if this is your very first time doing acceleration, then that is awesome. I'm going to show you exactly how it all works. But if you are a learner that's already done acceleration in class, there's a certain part that a lot of teachers and a lot of textbooks get wrong. What they say is that negative acceleration means slowing down and positive acceleration means speeding up. So maybe you're a learner that's been a bit confused about what is positive acceleration, what is negative acceleration, what is deceleration. Well, that's what we're going to talk about. Obviously, I'm going to explain from the very beginning. I'm going to explain all the basics, but then I'm going to show you exactly what is positive acceleration, what is negative acceleration, and deceleration, and all of that. Okay, because I know there are a lot of learners that get a bit confused in class when teachers, because different textbooks say different things, but trust me, I'm going to show you the proper way to handle these questions and the proper meaning of negative acceleration, positive acceleration, deceleration. Okay, Kevin, you're repeating your intro like 3 times, bro. They get it. Let's go. Right, so the formula that I want you to know for acceleration is going to be A equals to the change in velocity over change in time. That is the formula of acceleration. And what does change in velocity mean? Well, it means the final velocity minus the initial velocity. So you're going to say final velocity minus initial velocity over the change in time. Okay, you could think of that as your final time minus your initial time. That is the formula. So the F and the F stands for final and the I stands for initial. So for example, you might have a car. Don't laugh at my car, please. Let's say this car is traveling at 2 meters per second initially. Initially means in the beginning. And then it drives to the right. And then over here, it has a velocity of, let's say it has a velocity of 7 meters per second. So then that would be your final velocity. That would be your initial velocity. Okay, so let's go do a whole bunch of examples. Like, have a look here. We've got lots of examples coming. So this one says that car moves from A to B in 5 seconds. Calculate the acceleration. Now, what is very important with these questions is that we choose a direction as positive. Okay, now I'm going to show you something over here in this first example. If you choose, because choosing right or left, there's no right answer. Well, there's no right answer. There's no correct way to do that. You could choose right as positive, but you're also allowed to choose left as positive. There's nothing wrong with that. That is your choice, okay? The answer that we get at the very end will be exactly the same. But now we're going to start seeing positive answers, negative answers, and I'm going to help you to understand all of this. Okay, so we know that acceleration is equal to this formula over here. Remember that the F and the I, they're just little subscripts. They're not like different variables. It's just like that, okay? So if we look, okay, so let's choose right as positive first. So we can see that this for the final velocity at B, this would be your final velocity, and this would be your initial velocity. So we would say 8, and it's a positive 8. Why? Because the car is moving to the right-hand side. We can see the car is moving to the right, and for this one, we said right is positive. Then we're going to say minus, because the formula has a minus in it, and then it's going to have a 5. Now, this 5 is also positive, because it's also going to the right. And then you're going to say over. Now, the time is 5 seconds. So you could say 5 minus 0, because the initial time is maybe 0 seconds over here. But when they don't give you an initial time over here, then you can just put a 5. Okay? You could say 5 minus 0, but it's not necessary. Now, if we had to go calculate that, that would be 3 over 5, which is 0.6. Now, the units of acceleration is meters per second, like that, but then you put a -2. If it's velocity, you put a -1, but with acceleration, you use a -2. Now, have a look at this, guys. We chose right as positive, so that means right is positive, left is negative. And we got a positive answer, so that means to the right. So because our answer is positive, that is called positive acceleration. And so what a lot of teachers do wrong now is they say, oh, look, the car is getting faster. So positive acceleration means that it's that positive acceleration means getting faster. But that's not true, because now I'm going to do the same question and now I'm going to choose to the left as positive, and I'm going to do the same calculation. So we're going to go like this. And it's the same formula, but now in the place of VF, you're going to plug in a -8, because we chose left as positive, which means everything to the right is negative. So over here, the car is going to the right, so that's why we're putting the velocity as a negative. Then the formula has a minus, okay, so we're going to put a minus over here. And, oh, by the way, I just want to label this as positive acceleration. And now the initial velocity is 5, but it's also going to the right at that point, so we're going to say -5. So you see how we've got a -5 over there. And then the time, that's always a positive. You can't have a negative time. Now, if you had to go calculate this, you're going to end up with -0.6. Now, here is where many teachers and many textbooks get this wrong. They say, oh, look, the acceleration is negative. So what that means is that the car is slowing down. That is not true. The car is definitely not slowing down. It's speeding up. So remember, what we then do is we go to the next line and we say that the answer will be 0.6 meters per second to the -2. Now, in this example, we chose left as positive and right as negative. So because we got a negative answer, that means the answer is to the right. And so you can see we got the exact same answer whether we chose left as positive or right as positive. It is your choice as a student whether you want to choose left or right as positive. Your final answer, as long as you don't make any mistakes, will be exactly the same. So, and in this part here, we got a negative acceleration, but that doesn't mean anything. It doesn't mean that we are slowing down. It just means that our acceleration is negative compared to what we chose as positive. That's all that it means. So don't think of positive acceleration as speeding up and negative acceleration as slowing down. It's not always true. Okay? In both of these examples, this car is definitely speeding up. It's not slowing down at all. So here's our next example. So I'm not going to do choosing left and right as positive from now on. What I'm going to do now is I'm just going to choose, for each question, we'll just choose one direction as positive. But if you chose a different direction as positive, that's perfectly fine. You may do that. Just make sure that you get the exact same answer at the end, with the same directions and everything. So if, for example, in the previous example, both of the answers said to the right and to the right. You mustn't have that different. If that's different, then something has gone wrong. Okay, so we know that the formula for acceleration goes like this. Sorry, that's a little subscript over there. Okay, so many times, by the way, in this formula, we don't use the TI because the TI is normally 0. It's only in some type of questions that we're going to look at in later lessons where we're looking at graphs where sometimes your initial time might not be 0. Okay, but for the most part, you're actually just going to fill in one number over here. You could say -0 like I showed you. But yeah, just keep that in mind, okay? So I'm going to choose to the right as positive. What I usually like to do is just choose the direction that the vehicle's moving as the positive direction. Okay, so let's go for this. So A is equal to, now your final velocity, it says the car moves from A to B. So B is your final, A is your initial position. So that's going to be 12 minus, well, we should always put the formula first. So VF minus VI over TF minus TI. And so that's going to be 12 minus, then the initial velocity is 20. And I'm putting positives for both of them because at this point, the vehicle is going to the right, and at this point, the vehicle is going to the right. And so we chose right as positive. Okay. And then the time is just going to be 4 seconds. And if we calculate this, we end up with -2. Now, here's where you need to understand your answer. It says the answer is negative. Now, we chose right as positive, so that means left is negative. So if you get a negative answer, then you're going to say, therefore, the acceleration is 2 meters per second to the negative 2, but then you're going to say left. Okay, now, in the previous example, what was the car doing? It was moving to the right. What were the answers? To the right and to the right. When the answer is in the same direction, when your acceleration has the same direction as the direction your car is moving, then that is called acceleration. Then the car would actually speed up. Okay? When your car or your vehicle is moving to the right, but your acceleration is to the left, that is when the vehicle would actually slow down. And here we can see this vehicle is slowing down. That is called deceleration. That is deceleration. That is not called negative. You mustn't think of negative acceleration as slowing down and positive acceleration as speeding up. Here we got a negative. The negative it's just negative based on what you chose as your direction. That's all that it is. But when a car is slowing down, that is called deceleration. Okay? So deceleration is when you slow down. So if a vehicle is moving this way, but your acceleration is that way, it'll slow down. If your vehicle is moving this way and your acceleration is also that way, your vehicle will speed up. If a vehicle is moving this way and your acceleration is this way, it will speed up. Okay, so yeah, that's quite important. Now let's move on to another example. So now the vehicles are going from A to B. So now we're going this way now. Now you can choose what you want as positive. It doesn't really matter. I'm going to choose left as positive. Actually, no, I'm going to choose right as positive. Now, because that part doesn't matter. It does not affect my final answer. Okay, so this will now be the final, and this is now the initial. Remember, the initial is the start, the final is the final. It's the ending part. So if we now go work out the acceleration, this 20 is going to be negative 20. Because the car is moving to the left, but I chose right as positive. So right is positive, left is negative. Now you're going to say minus. Now your initial velocity is going to be negative 5 because we chose right as positive, but this vehicle is going to the left. And then if you look at the time, it's going to be 3 seconds. Now, if you had to go calculate this, you're going to end up with negative 20 plus 5, which is negative 15 over 3. And so your acceleration is negative 5. Now, you can't leave your answer with a negative. What you do is you say acceleration is going to be 5 meters per second to the minus 2. Now, if you chose right as positive and you chose left as negative, then if you got a negative answer, that means to the left. So this vehicle, is it going to be slowing down or speeding up? It's speeding up because we're moving to the left and the acceleration is also to the left. But a lot of teachers at this step here, they would say, oh, look, the acceleration is negative. So that they would say, we're slowing down. Because they've read and they've learned that negative acceleration means slowing down. But that is not true at all. Negative acceleration does not mean anything. Negative acceleration is based on what you chose as positive. So if you did this question and you chose left as positive, you would never have gotten a negative. You see? So don't think of negative acceleration as slowing down and positive acceleration as speeding up. It's not true. All that you do to see if the vehicle is speeding up or slowing down is you look at the direction of the movement, which is to the left, and you look at the acceleration. It's also to the left. If those two are going in the same direction, the vehicle is speeding up. If those two are going in opposite directions, the vehicle is slowing down. Okay, here's another one. So for this one, we can choose anything you like as positive. Maybe for this one, let's choose left as positive. Don't spend too much time worrying about this part. You choose whatever you like. I would challenge you to actually try these questions using both, and you should get the exact same answer at the end. You have to get the exact same answer at the end. If you can do that, then you really understand what you're doing. Okay, so this would then be your final velocity because we're moving from A to B. So if we now go to our calculation, we're going to get, now, we chose left as positive, and over here, the vehicle is moving left. So we're going to say 4. Then there's a minus in the formula. Now, this part is going to be, it's going to the left, and we chose to the left as positive, so it's going to be a 10. Then your time is going to be 3. Now, if you had to go calculate this, you're going to get 4 minus 10, which is negative 6. Now, negative 6 divided by 3 is negative 2. Now, what we do is we always want to give our answer as a positive. Now, if you say to the left is positive, then to the right is negative. So this will be to the right. Now here, once again, we can see the vehicle is slowing down because the object is going this way, but the acceleration is going this way. And we can see the vehicle slowing down. It's going from 10 to 4. 4 more examples. A car is initially moving at 12 meters per second east. Okay, so let's just remember north, west, south, and east. So we're going in that direction over there. Over the next 4 seconds, it reaches a velocity of 18 in the same direction. Determine the acceleration. Okay, excellent. So draw a little picture for yourself. So there's a car. Just draw a box. It really doesn't matter. And it's initially going at 12. Okay, and it's going east. So we're going east. Then after 4 seconds, it reaches a final velocity of 18, and it's still going east. So to calculate the acceleration, we know our formula. Okay, and so your final velocity is 18. Now, we need to choose a direction as positive. So you can choose whatever you like. You could choose west as positive or east as positive. I'm going to choose to the east as positive. And so if we say 18 for the final, it's positive because it's going to the east, and we chose east as positive. Then there's a minus in your calculation. And then the initial velocity is 12. And it's also going to be a positive number. So you put a positive 12 over there. Some people are like, yeah, but Kevin, why are you putting it as a negative 12? No, I'm not. That negative is part of the formula. So if it was negative 12, I would have done that. Okay? But that negative is its own little thing. And then the time is just going to be 4 seconds. And so if you had to go calculate this now, you end up with 1.5 and then meters per second. Now, here's where you give the direction. So we chose east as positive, and we got a positive answer, so we can say east over there. An aeroplane begins from rest and begins traveling eastward along a runway. It reaches a velocity of 60 meters per second in 20 seconds before lifting off the ground. Determine the aeroplane's acceleration. Okay, so we've got an aeroplane, and it's initially at rest. When you say at rest, it means it's at 0 velocity, and it travels eastward. Okay, so remember north, west, south, and east, so it's going in this direction. Okay, so it's going like, it's going like this. And its final velocity before it takes off is 60. So I'm going to choose to the right or to the east as positive. It just makes the calculations a little bit faster. And because then you don't get a negative answer in most times. Okay, so then TF minus TI. Okay, so your final velocity is 60, but always make sure if it's negative or positive. Well, we chose east as positive. And at this point, the airplane is going east, so that's positive. So we could say 60. Now, 0 is just 0. You don't have to worry about negative 0 or positive 0. And then time is 20. And so if you had to work this out, you end up with 3 meters per second to the minus 2. Now, we chose east as positive. We got a positive answer, so we can say east. 2 more examples. Tony is driving along at 20 meters per second in a northerly direction. Okay, north, west, east, and south. So Tony's going in that direction. And he observes a red light, and he brings his car to a stop over 10 seconds. Determine the acceleration. Okay, so you can imagine this is a top view of Tony's car. So he has a top view of his car. The wheels sticking out the side. Okay, and Tony is initially driving at 20 meters per second. Then he's busy driving in this direction, in a northerly direction, and suddenly there is a robot, and so he brings his car to a stop. Stop means velocity is 0. By the way, these are me trying to draw tires, right? This is not actually like a robot or anything. This is me trying to draw tires of a car from a top view. So that means the final velocity is 0. And okay, so I'm going to choose upwards as positive. And so we can say acceleration is equal to VF minus VI over TF minus TI. Okay, so your final velocity is 0, so you don't have to worry about direction for 0. Now with your initial velocity, it's 20, but and we're going in this direction, and we chose that direction as positive, so we can put a positive 20, and then your time is just going to be 10 seconds, and so your acceleration is going to be -2. So because you're getting a negative answer, go to the next line, and then you could say 2 meters per second. Now, we chose north as positive, and south would then be negative. So you're going to say south. Now, you see how we got a negative acceleration, and our car is slowing down. And this is why some teachers are like, you see, negative acceleration means you're slowing down. But that isn't always going to be true. That is only true because the car was moving this way, and we chose this way as positive. But if we chose this way as positive, then you wouldn't have gotten that, okay? Then you would have just gotten a positive answer, and you wouldn't have gotten that negative. So it's all based upon what we choose as our positive direction. So I never, ever want you to get a negative acceleration like this and be like, oh, okay, so the car's slowing down. That'll only be true sometimes, but not always. Because if, as I said, if we did this question and I chose downwards as positive, let me actually show you. Oh, Kevin, come on, I want to be done. Sorry, guys. I have to show you. So let's do this question again. But now we're going to choose south as positive. Because we are allowed to do this. We can choose whatever we want as positive. Okay, so now your final velocity is still 0. Your initial velocity is 20, but it's going up at this point, but we chose south as positive. So this is actually going to be a -20 now. And then your time is going to be 10. And if you had to go calculate this, you would end up with 20 over 10, which is 2. Oh, look, we got a positive answer. So does that mean positive acceleration? Or does that mean we're speeding up? No, it's got nothing to do with that. So what we now do is we can just say 2 meters per second. And then have a look at this. We chose south as positive. We got a positive answer, and so we can just say south. Can you see that the answers are exactly the same, my friends? The answer will be exactly the same. Science would be absolutely horrible if you got different answers depending on what you chose as positive, because then there would be no actual answer. People would do calculations and they would be like, oh, bro, but yeah, I got a different answer than you, but that's because I chose the other direction as positive. No, it's not the way science works. If this car is accelerating in a southerly direction, then it has to be doing that no matter whether you choose up or down as positive. You choosing up or down as positive is just what you feel like doing when you do your calculation. Okay? So let's do another example. This is our last example. A train is traveling in a southerly direction at 30 meters per second. Okay, so let's draw a train from a top view of a train. And it's traveling in a southerly direction, and it begins to slow down and reaches a velocity of 20 meters per second in 1 minute. Okay, so here's our train. Kevin, that's lame. And then over here. And okay, so initially we are traveling at 30 meters per second. And then final, we are traveling at 20 meters per second. And so we're going in this direction over here. Okay, so I'm going to choose that direction as positive. But you could also have chosen upwards. It doesn't matter. You could have chosen north as positive. So let's go use our formula now. And so the final is 20, and it's going south, and we chose south as positive, so we can just put it as a 20, then put a minus. Then for the 30, we chose down as positive, and it's still going down, so that'll just be like that. And then for the time, be careful. These are all meters per second, and then they come along with minute. It's like, bruh, what are you doing here? So you need to change this to 60 seconds. Can't this 1 minute read the room? So 60 seconds. And so you're going to say -10 over 60. And so if you had to go calculate this to 2 decimal places, you'll end up with -0.17. So now always leave your answer as a positive 0.17 meters per second. Remember, acceleration is with a 2. Now, we chose south as positive. That means north is negative. So if we got a negative answer, then it just means north. Don't say here north. No. You must always go to this next line where you put this as a positive number and then say north. Okay, guys, thanks for joining. Hope that all makes sense.